Hey everyone, welcome to this explainer. I am so incredibly pumped to have you here today. If you're looking to really wrap your head around the mechanics of industrial construction, you're in exactly the right spot. Today, we're zooming in on section 2.10 of our source documentation to look at a highly critical, foundational step in plant equipment installation. And you know what's crazy? We're talking about something that's totally overlooked once a project is finished because, well, it literally gets taken apart and thrown in the trash. But without it, oh man, the most massive, multi-million-dollar industrial machines would quite literally lose their footing. We're talking about the art of mastering formwork. I'm going to walk you through this step by step, keeping it super accessible even if you've never even set foot on a heavy construction site before.
Okay, let's dive right into this. Picture this, you're a rookie engineer, right? You're standing on this bustling construction site, staring up at a newly leveled, absolutely massive piece of industrial equipment. Maybe it's a towering vertical pressure vessel. It's been meticulously chipped, padded, and erected. Now, to permanently lock that heavy base to the concrete foundation beneath it, you gotta pour in thousands of kilograms of non-shrink liquid grout. Now, grout is basically this highly fluid, super heavy mixture, kind of like cement, but specially engineered so it absolutely doesn't shrink when it dries. So here is the million-dollar question. Before that liquid stone actually cures and hardens, how on earth do you hold all of that immense, flowing weight in exactly the right place?
Well, the answer to that brings us to our core focus today, formwork. Formwork is essentially the temporary wooden mold that's meticulously crafted to hold that non-shrink liquid grout securely in place while it cures around a foundation. Now, I want to bust a major myth right out of the gate. A lot of beginners look at formwork and think, oh, it's just some scrap wood and basic nailing. Anyone with a hammer can pull that off. No way. That couldn't be further from the truth. This is a highly specialized task. When you pour in that heavy liquid grout, it acts exactly like water, pushing outward with just incredible hydrostatic pressure against the walls of the mold. If those walls give out, you've got a severe structural disaster on your hands. So let's play forensic investigator for a second and analyze a real-world amateur mistake. It's a textbook example of exactly what not to do. Notice the thin, flimsy wood panels being used in this kind of setup? When you pour dense, heavy liquid grout into a weak mold like this, that outward pressure we just talked about is going to be absolutely immense. These thin wooden boards, they're just going to bow outward, and honestly, in a lot of cases, they'll completely snap and fracture right under that massive weight. Seriously, it's like trying to hold back a flash flood with a piece of wet cardboard.
Now, what's really wild is what happens when those amateur boards actually come together. Or actually scratch that, when they fail to come together. Let's really zero in on the total catastrophe waiting to happen right at the corner joints. Look at the visible, jagged gaps that often form there. Non-shrink grout before it cures is incredibly fluid. I mean, it's literally designed to flow into every single microscopic crevice under the machine. So if there's a gap between the wooden panels, or a tiny gap between the bottom edge of the wood and the concrete foundation, that liquid grout is inevitably gonna leak right out. It'll bleed all over your site, totally emptying the mold before it ever even gets a chance to harden.
So the crucial takeaway here is understanding the domino effect of these amateur mistakes. The consequences are honestly pretty severe. First off, as we just discussed, liquid grout leaks through even the tiniest gap, which means you're literally losing the exact material you need to secure the equipment. Second, that thin wood fractures under the intense pressure, causing a massive blowout. And third, and this is absolutely the most critical part, because the grout has leaked out, you're left with hidden empty voids right beneath your massive equipment. The foundation's integrity is completely compromised. When that machine finally turns on and starts vibrating, those empty voids are going to lead to catastrophic structural failure. And all of this is exactly what happens when someone decides, we don't need to hire a professional carpenter for this.
All right, let's pivot from absolute disaster to true craftsmanship and look at the proper way to handle this vital task. Let's compare that amateur approach with the structural mastery a real professional carpenter brings to a site. The amateur? They give you flimsy, gap-filled wooden panels just kind of slapped together with basic nails. But the professional carpenter arrives with thick, heavy-duty structural timber. They actually calculate the pressure. They design completely seamless joints. They aren't just building a wooden box. They are engineering a temporary pressure vessel specifically designed to hold back a liquid rock slide. And visualizing these two approaches side by side brilliantly illustrates the exact difference. On one hand, you have that jagged, leaking amateur gap we were just talking about.
But on the other hand, you have a completely seamless joint crafted by a pro. Notice the incredibly thick timber they use. Notice the perfectly flush V-cut joint. The professional uses a single, continuous, carefully angled piece of wood to wrap right around the corner, which effectively eliminates the joint entirely at the absolute weakest point. And where there is no gap, there is absolutely zero risk of the liquid grout leaking out. Honestly, it's a thing of beauty.
Now check out the incredible detail on the very top inside edge of a professional setup. Do you see that little triangular piece of wood resting there? That right there is called a chamfer strip. You see, a professional carpenter doesn't just stop at preventing leaks. They're already thinking 10 steps ahead to the final product. Concrete and grout, when they dry into a sharp 90-degree corner, are super brittle and will easily chip or crack if a boot or a tool just bumps into them. By placing this chamfer strip perfectly level with the top elevation of the pad, the carpenter makes sure that when the wooden mold is finally stripped away, the hardened grout will have this flawlessly clean, beveled, and highly durable angled edge. It's just a masterstroke of detail.
So as we pull all these lessons together, let's quickly recap the absolute non-negotiable rules of the site. Think of this as wisdom passed down from a seasoned construction mentor, okay? Rule number 1, always use sufficiently thick timber to withstand that intense hydrostatic pressure. 2, ensure absolutely zero gaps between your wood panels. 3, ensure absolutely zero gaps where the wood meets the foundation base. And 4, always utilize a professional carpenter. Absolute clearance control and the total elimination of any gap is absolutely paramount. That's how you ensure that the multi-million-dollar equipment sitting on top operates safely for decades. I want to leave you with this final, kind of wild thought as we wrap up today's explainer. Could a single, tiny gap really be the downfall of a massive industrial foundation? Well, as we've seen today, the answer is a resounding yes. A tiny millimeter gap drains the grout, which creates a hidden void, which eventually cracks the foundation, and ultimately, it destroys the machine. It really gives you a profound appreciation for the invisible craftsmanship, those temporary wooden molds, and the meticulous details that silently uphold the massive industrial worlds all around us. Definitely keep this in mind the next time you walk past a construction site. Thanks so much for hanging out and learning with me today, and hey, keep that curiosity sharp.